Welcome to the session on binary search. In this session, we learn about one of the searching techniques called binary search. Searching algorithms in general help in checking the presence of an element within the supplied set of data elements. There are many algorithms available for searching an element. Each of these algorithms are based on certain techniques. One of the searching algorithms is the linear search, wherein every element in the given data set is compared with the search element. Here, brute force technique is used. The other searching algorithm is the binary search, which is based on the technique called divide and conquer. The binary search requires the data elements which are to be searched being arranged in a specific order, and this order can be either ascending or descending. For the illustration purpose, let us consider the elements being ordered in the ascending order. Let's consider a data set consisting of 5 elements stored in some physical memory. We can call it as an array. An array of elements, 5 in number, are stored in the ascending order. A number 40 needs to be searched in this array. In this array, 40 is present in the 4th position, as you can see in the slide. Since the elements in the array are arranged in an ascending order, the first step before we start searching is to check if the search element is equal to or greater than the first element of the array. In this case, the first element is 10. Since the search element, that is 40, is greater than the first element, the search element is likely to be present after the first element of the array. The other check is to compare the search element with the last element of the given array. Since 40 is less than 50, 50 being the last element of the array, there is a likelihood of the presence of the element 40 anywhere in between the first and the last elements of the given array. As a next step, we now have to look at applying the divide and conquer principle. Rather than searching all the elements in the given array, divide and conquer principle suggests divide the given problem into 2 halves and identify that section where there is a likelihood of the element being present. So if the element is present, well and good, or else further continue the process of division until you are able to search the element or you reach one element being left out at the end. So now we look at dividing the array into 2 halves. To do this, we define what's known as low and high position for this given array. In this array, which we are considering for illustration, the low position L is initially set to position 1 and the high position is set to 5. The mid position has to be calculated now. Why we have to go for mid position? We need to now start dividing this array into 2 halves and then start searching in one of the halves where there is a likelihood of the element being present. To find the mid position, we take the starting position plus the end position divided by 2. So in this case, it is 1 plus 5 by 2, so which is 3. So 3 is the mid position. The element that is present in the mid position, 3, is 30. By calculating the mid position, we are able to now divide the array into 2 parts. Next step, we compare the element 40, which is the element to be searched in this array, with the element value that is present in the mid position. The element in the mid position is 30. Since the search element 40 is greater than 30, and also the data set in the array is arranged in the ascending order, if at all 40 is present, it has to be present in the right half of the divided array. So now we shift our focus to the right half. So we start now searching in the right half whether the element 40 is present or not. In order to carry out these steps, what we do now is the left position, which was initially set to 1 when we considered all the elements of the data set, now will be changed to mid plus 1 position. In this case, the L position will now be pointing to position 4 because the mid position was earlier 3, mid plus 1 is 4. The high position will remain the same. So now the low position is 4 and the high position is 5. We now calculate the mid position again for the right half of the array, which is 4 plus 5 divided by 2, and in this case the mid position happens to be 4, as you can see in the illustration. Now once we get to the mid position, the element in the mid position is being compared with the search element. As you can see, the element in the mid position is 40 and the number that we are searching is also 40. So there ends the problem. The element 40 is present in the fourth position in the given set of data and hence the search stops. This is how we have got the binary search implemented using the divide and conquer principle. Please remember there are two basic steps involved here. First, dividing the given array into two halves, and which might happen repeatedly until we reach the element or until the array gets reduced into a single element. And the second basic operation is comparison of the given search element with the elemental value of the mid position in the given array. Hence the index that is returned is 4. Let's quickly look at the algorithm associated with the binary search and compare it with the illustration that we just had while searching the element 40. The algorithm says that initially set the low position value to 1 and the high position value to n. Again, referring back to the previous example, the value of n is 5, the low position is 1. We have now a check while high is greater than or equal to low, which is true because initially the value of n is 5, 5 is greater than the low position, which is 1. We calculate the mid. The mid is 1 plus 5 divided by 2, which is 3. So the mid position calculated is 3, as you can see in this step. The element that is present in the mid position, if I again go back to the previous example, the search element is 40 and the element in the mid position is 30. So this 30 which is present in the mid position of the array is not equal to the element 40 because 40 is the element that we are searching. So hence this if condition becomes false. So now we check whether the element in the mid position is lesser than the search element. In this particular case, the answer is true here because the array in the mid element in the given array after one division is 30 and 30 is less than the search element, which is 40. So now we shift to the right part of the array by setting the value of low from 1 to mid plus 1. So now the low position becomes mid, which was 3 here as calculated, 3 plus 1. So low becomes 4. So now we have low is equal to 4, the high position will still be 5. But remember now, while we calculate the mid position for the right part of the array, the value of the low is mid plus 1 and the value of the high is 5. So mid plus 1 is 4. So now when it comes to this step, because this is in a while loop, mid is equal to 5 plus 4 divided by 2. It will round this mid position to 4 and we check if the array in the mid position, that is array of 4, which is the mid position in the right part of the array, it is being compared with the search element. We notice here the search element 40 is exactly the same as the value of the data set which is present in the fourth position of the array. So because this condition is true, it returns mid, it returns the position where the element 40 is present. Again, referring back to the same example, the value that is being returned here is 4. This is how the algorithm is going to work based on the divide and conquer principle.